Two forces, P and Q, can be represented by a single force of magnitude 12 newtons. If the magnitude of force P is 5 newtons, which one of the following is a possible magnitude of Q? A question like this usually involves us understanding the difference between getting the maximum of two forces and the minimum of two forces. So what I think about is, how can I get the maximum of two forces? So the maximum will occur when those two forces are parallel to each other, and so we add them. The minimum of the two forces will be when they are 180 degrees away from each other, and then we will subtract them. So to answer this question, it's merely just a process of comparing the 5 Newton with the option and then seeing if 12 lies in that range. So for instance, if we compared A, so we want to do 5 and the option A is 20 newtons. The maximum will be 5 plus 20, which is 25. The minimum will be, and it doesn't matter which way you subtract it, let's just do 20 minus 5, 15. So anything between that range is possible. Now we are looking for 12. 12 is not within the range, so A is out. Then we check our next option, we'll go with 14. So we'll check 5 and 14. The maximum between 5 and 14, 5 plus 14, that gives us 19. And the minimum will be 14 minus 5, which is 9. Now anything between that is possible. 12 is between that. So this option is the correct option. And so the answer for 1.1 is B. Now question 1.2, which of the following statements best illustrates the concept of inertia? So inertia is basically the resistance to motion. So we go through our options, we look here, a ball moving through a vacuum in space. So because the question, this option is not too clear, how is it moving? Is it moving because of some propulsion? There's not enough information to warrant us choosing that option, so we won't go with option A. Option B, an object comes to rest after the force acting on it is removed. So this lies more on the idea of friction. So this could be friction. C, the driver of a car moves in a forward direction when the car suddenly stops. And inertia is basically this. It's the idea that your body wants to resist the movement that is currently occurring. So if you're sitting in a car and the car is turning to the left, your body seemingly wants to go right because your body wants to continue in its straight motion. If you're turning to the right, your body seemingly wants to go left. If you're braking, your body seemingly wants to go forward. So that's the concept of inertia, where your body wants to, or a body wants to oppose that motion that's being imposed on it. So the option here for 1.2 we'll go with is C. We'll go on to question 1.3. 1.3 says, an object of mass m is pulled up a rough incline at a constant velocity as shown in the diagram below. Which one of the following equations is correct for the relationship between the forces acting on the object? So a few things stand out to me here. When I see this question, I'm reading pulled up an incline at constant velocity. So if there's a constant velocity, it means that the acceleration is 0. That means that F net is equal to 0. Now, if I draw a free body diagram, the free body diagram will look something like this. So I will have a force of gravity that points down. I will have a force applied here. I will have a friction force like so, and then I will have a normal like this. Now, because it's on an incline, because these forces have angles, we need to break these forces up into components. So the force applied obviously will be broken up into a component, and the component that we're going to be interested in is going to be the x component, so Fx. The force of gravity, that's going to be broken up as well. That's going to be broken up into two components. We're going to have a component here that's going to be going down the slope. That's going to be Fg parallel. And then we also have the one that is opposite the normal, which is Fg perpendicular. Now, since this object is moving on the slope, we are simply interested on the forces that are acting on this plane. So the forces that we're going to concern ourselves with is going to be the Fx, it's going to be F, and it's going to be Fg parallel. Now, because the F net is 0, it means that those forces are going to equal one another. So we can write a statement like this. We can say that Fx, and assuming up the slope is positive, Fx is going to equal friction plus Fg parallel. Now all we need to do is we need to look at our options and see which one matches. So Fx will correspond, well, there's no Fx here, so let's just expand this. So Fx is going to equal, and we know the expansion for Fx, that's F cos theta. But we don't have theta, we have A. So F cos A is equal to friction plus, and Fg parallel, we know from the expansion that that is equal to mg sine theta. So F cos A is equal to F plus mg sine theta. So we just need to pick out that option, and if you notice, option B is basically the option that we have. The only thing that they've done is that they've transposed or taken this across. So 0 is equal to mg sine theta plus friction, or Fk, minus F cos A. So that is option B. Let's move on. Question 1.4. Two charged objects repel each other with force F when they are separated by a distance d. So here and here, distance d. Now there is a force of F between them. The distance between the same two charges is reduced to half. So we are halving the distance. So what happens to the force? Okay, so we'll start. We'll say that F is equal to kq1 q2 over r squared. And that's our main equation. Now they've reduced it. They've halved the distance. So we'll say F is equal to kq1 q2 divided by half r squared. Now, if we expand this, so open up the bracket, we're going to get kq1 q2 divided by a quarter r squared. If we take this quarter and take it out to the front, it becomes 4 over 1 when you tip in times. So dividing by a quarter is the same as multiplying by 4, in other words. So 4 kq1 q2 over r squared. Now that is F. So it's 4F. So the answer here is going to be D. And moving on to the last question, which is the electricity question. The diagram below shows two light bulbs, P and Q, connected in series to a battery. If bulb P glows brighter, so when I think of brightness, we think of power, then the. Okay, so what I'm noticing here is that this is all in series. And so when we're talking about circuits in series, more often than not, we're going to use the power formula I squared R, since I is constant in series. When we're talking about power in parallel, more often than not, we'll use the equation P is equal to V squared over R. So it's not always the case, it's just easier to work with it like this. So P is equal to I squared R, and if we're comparing P and Q, since the current is the same, the power is going to be directly proportional to the resistance. So since P is brighter, it means that P is going to have a greater resistance. So the answer is going to be A.